It's always about a number, that's with any type of traffic.
Greetings, what's happening, y'all? This is Bishop Grady, aka Professor Grady, and we are exploring the fundamental principles of mathematics, and that is arithmetic. And digging into arithmetic, if you've seen this, hopefully you've seen the previous video where we went over the addition of single-digit numbers. Right now, we are going to get into subtraction of single-digit numbers. Addition and subtraction are basically inverses of each other. Whereas when you're adding stuff, you're combining them. When you're subtracting, you're taking away. So we will start with writing out a problem. Just in case you didn't see our addition video, you know, we'll give you a brief overview, really quickly for those who have seen it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When it comes to understanding addition and subtraction, it's great to use number lines. It's also it's also a good introduction and leeway into algebra. So likely if you're seeing this, you're either a kid in grammar school or you're tutoring or teaching a kid in grammar school. You have a kid in grammar school. So it's great to know that whether they're in kindergarten, first grade, or whatever, if they can learn to understand addition and subtraction, then they'll be able to at least visually comprehend what's going on in algebra. I've tried it with my own daughters, it works. Nevertheless, we'll count these numbers out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so that we don't have to use our fingers, but it's essentially the same thing. You have 10 fingers, including your thumb. You have 10 fingers. Here we have 10 numbers. And 0 is basically nothing, your fist up, whatever, represents no fingers, right? So when you're doing addition, you're always going in the direction of ascending or increasing numbers. In this case, it's to the right. So anytime we do addition, we're doing a number line, we're doing it to the right. We're adding, like say we add, what is 2 plus 3 equal? Well, we start at 2, then we add 3. So we start here, 1, 2, 3. By counting towards the right, we're adding 3. So we start 2, 1, 2, 3. We end up, we end up at 5. 2 plus 3 equals 5. You can do that for any combination of numbers. If I want to say 1 plus 7, start at 1, 1, 2, 3, 4, 5, 6, 7. Now I got 1 plus 7 equals 8. You know what I mean? So we can do that with addition, but now subtraction is different. And you heard me say that it's kind of the inverse of it. Subtraction, we're going in the opposite direction whenever we subtract. Now addition, let me say that addition is considered a commutative property, meaning that no matter what order that you combine these numbers in, you're going to get the same amount. So 2 plus 3 equals 5, 3 plus 2 equals, well, let's try it out. We start at 3, and let's count to 2. 1, 2. That also gives us 5. 3 plus 2 equals 5. Right? We start with 7. What's 7 plus 1? 7 plus 1 equals 8. This makes addition commutative. You know what I'm saying? You come the same way, you go the same way, you're gonna end up in the same places. Commutative, right? Subtraction, however, does not work like this. It is anti-commutative, meaning if you change the order, it actually changes the number. I'll get into more into that. But now, what are we dealing with when we say, when we're talking about subtraction? Well, subtraction, notation-wise, it looks like 5 minus 2 equals what? Now, this is considered, just to be technical, for those who are really learning it and maybe need to pass the test. You have your minuend, you have your subtrahend, and the difference, which would be the answer to this mathematical problem. 5 minus 2 equals what? Or 5 minus 2 equals what? Question mark, let the question mark represent what? anytime you subtract, but it's the same way that I taught y'all how to do addition. You start with the number here that's on top, or the number, you know, to the left. You start with 5, and then when you subtract, instead of going to, if it was 5 plus 2, you'd be going to the right, but since it's 5 minus 2, you're going to the left. So 5 minus 2, all right, well, let's start at 5 and subtract 2. So we count to 2 in the other direction. 1, 2. And that leaves us here, which is 3. Oh, okay. So that means that 5 minus 2 equals 3. 5 minus 2 equals 3. Right? And mind you, you can also do this with your fingers, of course. If I say, what is 5 minus 2? You start with 5 fingers, and you basically count by taking away fingers, and you'll get your answer. So 5, all right, so I count to 2 and while I'm taking away fingers. 1, 2, and I end up with 3 fingers, right? Or, you know, 1, 2, however you want to do it, right? And that's pretty much the concept. So it works with any number. If I wanted to say, all right then, well, what is 7 minus 5? What does that equal? Oh, okay, well, you start at 7, like so, and we'll get rid of this here, whatever. We're still dealing with the same number line. So you start at 7, you go again, we're subtracting, so you go to the left and count to 5. 1, 2, 3, 4, 5. And where does that leave us? 2. Okay, so 7 minus 5 equals 2. Right? 7 minus 5 equals 2. I love you crazy kids are writing it today. All right. Now that works with positive numbers. Well, what about negative numbers? What about that? See, the great thing about how Professor Grady teaches, you know, kids, adults, or whoever, is I'm gonna make sure that you understand it on every level. A lot of people don't know how to manipulate negative numbers until they get into an older grade, but a kindergartner can understand this. So you have the addition of we're gonna bring negative numbers into the number line, right? So the same way how we count that way, when you're in the negative, in the negative world, everything's reversed. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So look, -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. Now this number line, as I said in the last video, you know, these arrows represent the idea that it can keep going forever. You know, it doesn't have to stop at 10. You can stop at 10 gazillion. You know what I mean? Or -10 gazillion. But we're gonna stop at the 10s right now. So this whole idea of addition and subtraction, as I said already, it works with negative numbers as well. As long as when you are adding, you go to the right, in this case, and when you are subtracting, you go to the left. All right, so what is 3 minus 5? Wow, 5 is greater than 3. And you know, essentially they try to admit that, you know, when I was younger, they tried to teach us to not do this, that, you know, in order to subtract, the number has, the minuend has to be greater than the subtrahend. And you know, told us that until we got old enough to really understand negative numbers. But with the number line, you don't have to do that. We get straight into this, and you'll prep yourself in order to learn higher mathematics, like algebra, like calculus. 3 minus 5 equals what? Or we can also write it 3 minus 5 equals what? So we start at 3, and we go to the left, right? 1, 2, 3, 4, 5. And where does that land us? Oh, -2, okay. So 3 minus 5 equals -2. You get what I'm saying? Let's try some different combinations. What's 10 minus 1. 10 minus 1 equals, well, we start at 10, and we just count to the left. 1. All right, 10 minus 1 gives us here. All right, 10 minus 1 equals 9. All right, let's try that a different way. What is 10 minus 11? Whoa, 10 minus 11. Well, let's count. You know what I mean? You can do your fingers, but you don't have 11 fingers. This is also where a number line will come in handy. But nevertheless, we can start at 10 and we count to 11 while going to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, so 10 minus 11 equals -1. All right? Now notice, like I said before, subtraction is not commutative. Notice how if I switch these, it's anti-commutative. When I switch these, all right, well, let's try what is 1 minus 10 equal? Or what is 1 minus 10 equal? All right, well, if we start at 1, let me erase some of these previous problems. Give me a second. But if we start at 1, anytime we're subtracting, we're going towards the direction of decreasing numbers. In this case, that is to the left. We are subtracting, we are going to the left. Right? If we start at 1, okay, we'll start here, 1, and we go towards the left while counting to 10. So we start at 1, then we go to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, okay. So we got 1 minus 10 equals, what's this? -9. -9. Now notice how -9 is not +9. This is -9, this is +9 over here. That is why subtraction is anti-commutative. I'll write it out for you. Anti-commutative. Alright? Same thing that happened with, now if that's true, if we expected an inverse, if we were to switch it around, then that would mean that 11 minus 10 should equal 1. Right? Let's try it out. 11 minus 10 equals, we start at 11, which would essentially be the next number over here. Let's start at 11. And we subtract 10. Well, if we subtracted 10, we're going towards the left by 10, right? So we start here and we count towards the left 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, okay. So 11 minus 10 equals 1, which is the inverse of -1. So the additive inverse, that is. So what have we learned today? Well, we've learned how to subtract single-digit numbers. We've also learned what commutative and anti-commutative is. We've also learned about additive inverses, meaning if you have a number like 8, the additive inverse of that number is -8. You know, if you have a number like 1, the additive inverse of that is -1. And we will stop there. Now, one important concept that I haven't covered in the addition or subtraction video that should be shown here is the power of 0. But you know what? I'll get into that into the next video. Thanks for tuning in and be on the lookout for graduation party 2.